In this short video, I wanted to run through an example that I get asked about a lot about the equals method. So this is the equals method in our student class, and it overrides the equals method from the object class. That means it has the exact same method header, public boolean equals, taking in one parameter of type object. So this is the standard structure for the equals method. Again, the parameter type is object. That's because it's overridden from the object class. So the question I get a lot is, how come we can't just write the equals method like this? This equals method would be a lot simpler, right? Because I wouldn't have to worry about the type of the parameter. I already know that it's a student, and so I could just say, all right, well, to compare two students, just return whether the ID of my current student is the same as the ID of my other student. And I don't have to worry about checking the instance of, I don't have to worry about casting or any of that. Obviously, this is a much simpler method. So this little example here is going to show why this doesn't work. Now, first of all, we'll know that as a compile time check that this is not the proper overridden version, because if I add the @override annotation, you can see that, oh, there's a problem here. There is no method that's being overridden. So I know for certain that I'm not overriding the version in the object method, or I'm sorry, in the object class. But again, the question I often get is, well, so what? Why does that matter? So if we had a class that created some students, here we create 3 students, and then let's create a 4th student with the same information as S1. So we have S1 with the ID 1234 and S4 also with the ID 1234. Again, you can think about in a realistic setting, maybe you were drawing data from one place of your database about students that are enrolled in a course, and then data from another place in your database about students that owe tuition or something like that, and you want to compare your 2 lists. So what you really want to know is whether this student S1 is the same as, quote, student S4, and the same as meaning how we think about it, which for the student class we've defined to be having the same ID. So if I comment out my other equals method, so the only equals method I have right now is this one that takes a parameter of type student, and I run this program. Sorry, let me just comment out what's coming next. Invoking the equals method, it's going to tell me that the 2 objects are equal. S1 is equal to S4. Because when I invoke the equals method here, it's the type of the both actual and declared type of S4 is student, so it invokes the equals method that takes a student, which is this one. And that tells me that the 2 students are equal. Now that's actually the same thing that would happen if I had both equals methods, right? So I could have both these methods in here, and this one would still be invoked because the declared type of S4 is a student. So again, still I would invoke, still the method that would be invoked would be this version of equals, and I would get the same result that these 2 objects are equal. So again, this is sometimes the example people think about when they think, okay, so the equals method works just fine when I take in a parameter of type student. Why do I have to take in a parameter of type object? And it's true that if you were to directly invoke the equals method, this would be okay to do. This would work how you think it should work. But it's not always the case that you're going to directly invoke the equals method. Sometimes you're going to be using another method that behind the scenes relies on the equals method. And in those cases, you cannot use this version of the equals method. So let's take a look at that. So let's now say that instead of just directly comparing these 2 objects, let's say we put our first 3 students into an array list, and then we wanted to see if S4 was in that list. Now, from our human perspective, S1 and S4 are, quote, the same. So if I add S1 to the list, and then I want to know if that list contains S4, this should give me a result of true, right? Because S1 and S4 are, quote, equal. They are, quote, the same. But when I run this, I see I still have my true from this first call here. But now when I ask if the list contains S4, I get false. Now the reason I get false is because the contains method of the ArrayList class relies on the equals method. But what equals method? It's the equals method that takes a parameter of type object. And right now, because this is commented out, my student class does not have a method called equals that takes a parameter of type object. So what's happening is that instead, the contains method is just relying on the version inherited from object, which just compares whether S1 and S4 are aliases. And we know that S1 and S4 are not aliases. They're actually two distinct Java objects. They just happen to point to the same information as humans think about it. So they're not aliases, which is why the contains method, when it invokes the object version of equal, returns a false. So hopefully this example will help if you want to understand a little bit more about why this is not the proper version of the equals method. And instead you must override the version in object, taking in the parameter of type object, in order to be able to use the equals method in all the other kind of ancillary methods that use it, like things like contains. So if we get rid of this incorrect version and rerun our program, we'll now see that both when we directly invoke the equals method, we get true, and also when the contains method uses that equals method, we also now get true. Okay? So if you have questions about this, please post to the forums, but hopefully this helped clarify why it's critical to override the object version of equals rather than to write one that takes in a parameter of that particular class.